I'm Mateusz Szostok. I'm software engineer at SAP Labs Poland. Basically, on daily basis, I'm a Schema developer. I'm also Kubernetes member and Kubernetes Service Catalog SIG chair. Today, I want to take you on a journey that will show you how to migrate from aggregated API server into CRD approach. Basically, the whole story took us around 5 months, so it was hard to squeeze all those information into 30-minute talk, so it will be more like a journey of highlights. But still, what you will learn is a technical implication of aggregated API server and CRD. Basically, why it's worth to migrate into CRD and invest your time into that, and how to migrate custom API server features into new approach. What is important is that we migrated not a tiny service, but a project developed under Kubernetes for 3 years. And basically, it's a journey, so it would be good to start from the beginning. And the whole story started in Schema. For those who don't know, Schema is an open source project built on top of Kubernetes, with all batteries included. I mean logging, monitoring, authorization, authentication, and so on and so forth. Thanks to that, you can focus on building your business application. What's more, Schema was designed to extend monoliths and legacy application in a cloud-native fashion. To do so, we introduced application connector concept. And that guy allows you to connect your monoliths into our platform. Thanks to that connection, you will receive events, and you can also hit your monoliths using REST API. What is important in Schema, from the day one, we decide to use CRDs for extending Kubernetes. So that area is based on CRDs only. Next one, we have a built-in serverless components. In that place, we have a cooperation with the Knative guys, so it also runs with CRDs. The last pillar that we will focus on is the service management. Service management allows you to consume third-party services and manage them. Here we decide to use Kubernetes Service Catalog. Service Catalog basically is a platform where you can register a broker compliant with Open Service Broker API spec. So for example, you can register GCP broker. Thanks to that, you will see offering from GCP on your cluster. Then you can choose one of that service, fill some input parameters like name, DB size, and so on, create an instance. Instance will be created on the GCP side. When instance will be ready, you will receive information that is running. After that, you can create a binding. Because you have an instance on GCP side, and your business application is inside your cluster. Binding means injecting all necessary information to your application, which you will use to connect that instance. For example, URL, password, and username, right? So to implement that logic, Service Catalog basically extends Kubernetes with 6 custom resource definitions, with 6 kinds. And it's basically a really awesome concept, but how Service Catalog implemented that? To answer that question, I need to say that Service Catalog was started by Google's almost 3 years ago. At that time, extending Kubernetes, you could extend Kubernetes only using aggregated API server. And who knows what it is? Okay, so that's good. So I will just briefly describe that. Basically, when you're operating on core resources, you are hitting main API server, and your manifests are saved in underlying etcd storage, the main one. When you want to extend that with your manifest, with your kinds, basically you are adding new API server with own etcd storage where your manifest will be stored. When user want to get them, is going through the main API server, but in that time, this guy is only proxying that call directly to your service. And here is the whole logic. And it sounds okay-ish, but we had a few problems when it comes to running that application on our cluster or adding new features into Service Catalog. So reason one, this approach requires you to write from scratch API server. And basically, you need to maintain that code. When I'm saying maintain that code, I'm saying a lot of code because you need to create for each of your kind strategy and storage connection. Problem is that with that is that code grows with additional fixes, additions, which can be globally crappy if you have a lot of code in your repository. Next thing is that if you are owning a lot of code from API server, you are also owning some core concepts, like incrementing generation field. It's a core concept, not a business logic at all. So it's really hard because it's easy to introduce the bugs, and it's hard to follow best practices from general API server machinery. Next one is also really hard to be in sync with Kubernetes version. Why? Because when you're bumping your dependency, then you have a lot of changes. And not only in vendor folder, but also in your files, because you are owning API server. So you need to track which method was deprecated, replace it with new one, or adjust your interfaces for your functions. It's problematic. So a lot of manual changes in case of bumping to Kubernetes version. Next reason, I love that one because not everyone remember that, but open source project is like a living organism developed by people who come and go, or sometimes only go. In case of service catalog, guys who implemented API server are not there anymore. And there's, of course, a promise we'll write a documentation, but it's not always true. And new contributors slowly violate unwritten rules. And in case of API server, for example, you can set defaults in 3 different layers. So without best practices, you can do it in different layers, and it's messy. So it should be, you should choose such architecture which allows you to do that only in one way. It will be the best for you. Last reason from my list, I think the most important one is owning etcd storage. It's problematic. Why? If you're running your own Kubernetes, it's good because you can configure that API server to reach your main etcd. But in case of managed GKE, of managed Kubernetes cluster like GKE, AKS, and so on, this is a control plane. You don't have access to that thing. So basically, you need to deploy your own etcd storage, do backups, upgrades, and so on and so forth. It's really problematic. What's more, there is quite nice thing. When etcd is down, AP server is also down. So Kubernetes cannot see your resources. So for example, you can delete namespace where they were created. When your API server is back, then you have a resources in namespace which does not exist. It's really problematic for us, and we have a lot of problem with such things. So owning etcd is not a good thing, but there is a new kid on the block. I mean CRDs, which last week were promoted finally to GA stage, general available. In Kubernetes, it means V1 version. It's super cool. So basically, we already know how CRUD operation looks like with API server. With CRDs, it's really simple, like child's play. Basically, what you have only custom resource definition YAML files, and you need to specify versions and names, and also scope. Nothing more. API server will take care of your resources, and we process them and store in main etcd server. So it's really super cool. And I think that talk about Kubernetes without mentioning KZ Hightower is really uncommon. So as a summary, I want to say that no code is the best way to write secure and reliable applications. I think that's the best thing in our system. But API server is not only about CRUD operation, create, update, read, delete. It's also give us ability to intercept our request. Before storing our object in etcd, we can change them. How? Basically, I said that we need to create a strategy. For example, we need to create a strategy for create our resource. Thanks to that, we can default some fields. We can also add some information like who created that resource. It's cool. In case of CRDs, we are going through main API server and storing your object in main etcd. So it'd be cool to intercept that request somehow. And what is cool is that CRDs are shipped together with admission webhooks. You can use mutation webhook. How it behaves. Basically, you can register mutation webhook. API server will send you payload for resource that you subscribe. You can mutate that manifest and send back patch to API server. Each webhook will be executed one by one. How to register such webhook is really simple. You are using mutation webhook configuration, and you're saying, okay, call my service when pod will be created or updated. Nothing more, it's super easy. Next one is a schema validation. You need to validate your object, but schema validation is a static one. What I mean by that? When you're creating your custom resource definition, besides name and version, you can specify also validation entry. Here you can use OpenAPI schema to define that. I will have a spec entry with cron and replicas fields. And cron should be a type string with given pattern. It's super cool, easy, but it's static validation. When you need, when you need something more, you can use validation webhooks. For example, in that case, you can perform some external calls. It's really similar to the mutation webhooks. Basically, you will receive body, manifest, for example, for pod. You can validate, and then send response to API server. Deny or allowed. After that, your resource will be saved in etcd. So it's really easy. How you can register webhook? In the same way, basically. You're saying, okay, call my service when pod will be created or updated, but right now, in that case, you are using validation webhook configuration. That's it, nothing more. So, how to move your features from API server into CRDs? I've chosen 5 most important ones to show you how we substituted them in CRD approach. First one, sub-resources. Cool feature. Sub-resources allows you to define fine-grained actions on your kind. What I mean by that? User can write spec, controller write status entry. So in our case, status will be a sub-resource. Thanks to that, we will have a dedicated methods to update that entry, and we can also set different airbags. It's really useful. With API server, you need to write some code. Basically, you need to write storage connection and also create a strategy for saving and deleting that entry, status entry. What's more, I think it's more painful, is that you need to take care that when you're modifying spec entry, you will not edit status. And you need to do that for each of your kind. I think it's error prone because it's easy to forget about it. In case of CRDs, what you are doing, you are just defining one entry, sub-resource with status field. Nothing more, everything will be handled by main API server. Okay, there are some limitations, so be aware that CRD supports only scale and status sub-resources. For us, it was good enough to go. Next one, I really like that one, is a table converter. When you are executing kubectl get, by default, you will get name, namespace, and age columns, nothing more. But you can customize that output. Thanks to that, you can have a better user experience. With API server, when you're defining storage, you are also defining a table converter. I need to say it easy and simple, but with CRDs, it's also easy and simple. What you can do under your custom resource definition, you can specify additional printer columns. You are saying the name of that column and also JSON path to the value that should be displayed. Side note is that you also need to redefine age column. It will disappear. To be honest, I didn't have enough time to check if it's a bug or feature. We just redefined that in our case. But still doable. That's good. Prepare for create and update. I already talking a lot about strategy in API server. And we know that we have two functions, prepare for create and prepare for update strategy in API server. We already know that we should move them to admission webhooks, the mutation one. We already know how to configure that thing. We know that our service should be called, but how to write that service? What you can do? How to implement that service? Basically, in ecosystem, you have a lot of options. You can use controller runtime together with controller tools. You can use Kube Builder. You can use operator SDK. You can use meta controller, and probably something more. I will start with the last one, meta controller. First of all, you need to deploy that controller in your cluster. Then you can define Lambda in any language. So hooks can be written in any language. In that case, it's a JSON-net. You just receiving some manifest, applying some modification, and that's it. How you register that webhook? Basically, you need to use kind from meta controller. It will simplify writing your webhooks. Additionally, you will not have any direct dependency to Kubernetes in your webhook, but what you need to do is to deploy additional controller in your cluster, and you depends on support, Kubernetes support in that project. For us, it was not a way to go because we are already a core project under Kubernetes, so we cannot depend on different projects. Next one is a Kube Builder and Operator SDK. I will describe them together because basically they are almost the same. They are simplifying building process of Kubernetes webhooks and controller by scaffolding Go sources and package structure. So when you execute Kube Builder in it, then it will create such project structure. Thanks to that, you have all boilerplate in place. It's super cool. But it's cool when you are writing your service from scratch, or if you are creating a lot of webhook servers. Thanks to that, you will have the same boilerplate in each project, so developer from domain A can contribute to domain B without any problems, because they know everything about it by default. But for us, we already have a project. We have our structure, everything is there, so we wanted something more native. And Kube Builder under the hood using controller runtime and controller tools. So we decide to go with those libraries because those projects are set of Go libraries for creating and managing controller and webhook servers. What is important is that this project is developed by guys from SIG API machinery. The same guys who creating API server, CRDs, and other stuff in core Kubernetes ecosystem. So it's pretty safe to use it in your project. How it looks like? Basically, you are importing webhook package from controller runtime. And you can define your server just by providing port and TLS certificate. Nothing more. Then you have an option to register your webhook handler in given endpoint. Webhook handler is really simple. You need to implement admission handler interface. Basically, it means that you will have two input parameters. One is a context. Second one is the admission request. And you need to return admission response. Simple. In admission request, you will have body that you subscribe to. You can decode that. And you will have also action. So you can act on mutate, on create, and on update. Mutation and creation is really simple. Basically, you have already your kind, so you can set some defaults or restore some other fields. It's pretty simple. And after that, you are returning patch response back to API server. And that's it. Control runtime gives you all that sugar in your code. So basically, you are executing only functions from that library. So we migrated already our functions from my API server. Next one is a validation. But basically, we are using the same concept. So once again, we are defining our endpoints with handlers. do the registration, and handlers is the same interface, but what we are returning allowed or denied. Nothing more. It's even simpler. The last one, the last one is a field selector. Basically, when you want to retrieve org service instance with the same field value, you can use that option. We did it a lot in our code when we use API server. But in CRDs, field selector is unsupported. What's more, it's inefficient to implement it today. So basically, they said even that it's anti-goal for them right now. So we need to find out some alternatives. First one, probably already know that mom said we always should share. And what we did at the beginning, we created a shared informers together with indexers. So when you're creating your informer, you can register your own index. In that case, we are creating external name and saying that, okay, we want to be indexed by that field from spec entry. How to use them? Really easy. You're just saying, okay, get me all objects with the same external name key. Really simple, but shared informers and indexers are client-side. It's problematic. Because it's okay if you have long-running process like servers, because you can execute at the beginning, creating a shared informers, adding indexers, and then execute cache sync. And depends on the object in the cluster, it can take a while. In case of CLI, it's problematic, and we have one. We have a CLI for our project, and we need to populate cache from scratch for every comment. It's not the way to go. We cannot wait for cache sync for each comment. So what we did, probably all of us are working with Kubernetes, so know that you can query, you can get all objects using label selector. It's the native way to get more objects from the same, for example, environment. So what you can do is to just execute kubectl-get and specify label selector. So our approach in that case was to copy some fields directly to the labels entry. Maybe it's not really pretty, and it could be problematic, but in our case, what we did is to implement sync labels functions, which we are executing on each create and update function action from CRDs. So we always have those entries in sync. Thanks to that, previously we had a field selector when we were listing all objects. It was easy, and right now it is almost the same logic, because what we have a label selector. We have a key, with the name of that label and the value of that label, and we have the same interface here. We didn't change anything. So it was really good enough to go for us. So we did it, and we have a new architecture in place with CRD approach. What's more, we changed the backends without changing the API contracts. We only break the field selector. With CRDs, you are not allowed to query using field. Everything else is supported and already there. And the last thing, because we have a new version, and now it's time to migrate your clients. Our goal was to have one-click upgrades. To do that, we used Helm upgrade. Because we are already installing service catalog using Helm, so we decided to use the same mechanism to execute upgrade for our clients. Under the hood, there is we write tool in Golang to do the migration, and we are executing that tool for pre-upgrade hook and post-upgrade hook. Basically, what we are doing is to make API server as a read-only. Then we are scaling down our controllers, backupping all our resources. Then we are executing the normal actions, deleting all etcd, API server, and so on and so forth. What we are doing next, we are installing our new webhook server with new controller version. Then we're scaling up our controller, applying our old resources, adding some owner references for our secrets, and then controller is up and running. So we have a full migration. I will not discuss that into details because it's already a huge amount of information, and discussing that migration tool in details will be more like a new talk. So, things to take away. CRDs together with admission webhooks are production ready, and they are simplifying a process of extending Kubernetes. What's more, it allows you to benefit from implementation improvements of general API machinery because you are using main API server. It's super cool. Aggregated API server is still okay, but only for limited use cases. When you want to modify some core features, concepts, if you want to have generic sub-resources or still support some field selector, right? Then you need to go still with API server. What's more, as I said, it was just a highlights from our migration, but what we will create in near future some blog posts about the CRDs, webhook approach, how to write controllers and stuff like that, so stay tuned. And also, what is good to know, we have something like Kubernetes office hours meetings. Basically, you can call and ask some questions. It could be everything, because there are guys from different companies which are using Kubernetes on production and have a lot of experience with that. And also, you can reach me, hit me up. I will be today and tomorrow here. If you prefer online option, you can always find me on Schema Slack and also on Kubernetes Slack. I'm also on Twitter, so you can reach me out. If you prefer face-to-face meeting, I'll be also on KubeCon in San Diego. I will have 2 talks there, so you can always catch me up there. And from my side, that's it.